Okay, so welcome everyone. Today I will do my best to answer the question, is Flutter any good for enterprise-grade projects? But before we get started, I would like to introduce myself. My name is Jakub Biliński, and I'm an expert dev engineer at ING Poland. And we are developing a lot of cool projects. We are also using Flutter for quite some time. So today I would like to share with you why we are using it, what Flutter is. We are going to go from the basics. We are going to deep dive how it works. Again, then we are going to talk about when and why you can use it. We are going to touch a lot of topics, so I hope I will be able to do that in 50 minutes. So without further ado, let's get started. Like I said, let's get started with Flutter basics. If you Google what Flutter is, you will find something like this. This is from the official documentation. There's a lot of text, so there's no point of reading that. So in a few words, Flutter is a technology, a toolkit for creating multi-platform applications. Initially, it was created for developing multi-platform mobile applications, and it's still true, but Flutter can do much more than that. Currently, it can deliver applications for web platforms, mobile platforms, like I already said, and native platforms, desktop platforms, like Windows, Linux, and Mac. So it can do a lot of stuff, and it can do it really good with high performance. Let's continue. Mainly, I will focus today on the mobile platforms, because that's what we are doing today, but sometimes I will add something about other platforms. So when we are writing something in the Flutter, we are using Dart programming language. I will talk about that in a minute, but what you have to know at this point is that we are writing in a language called Dart, main base code, shared code between platforms, where the most of the logic is held in most applications. You know, the most business applications can be shared and should be shared, and some aspects that are really platform specific can be in the Flutter added. Like Java, Kotlin, and C++ from Android, and Swift and Objective-C on iOS. It can be then mixed, more or less for now mixed, and then we will get a final application that can be used on any platform that has, this is very important, consistent UI on many platforms that looks almost pixel to pixel perfect on different platforms, and that's very important because fixing bugs on production when we have different UI and different code base, like in most native applications, is very problematic. So with consistent UI and consistent base code, it can give us more people to work on bugs. I know not many people like bugs, but that's what we can work on more. Also, Flutter is great for creating great animated UI with declarative code that is easy to create. Creating something like that in other frameworks is possible, of course, in native applications, but it's very time-consuming. In Flutter, it's quite easy. Also, there's a hot reload. I know that probably most of you wrote some front-end application in HTML, CSS, and writing a front-end application is great because when we save a file, we can in almost seconds see the result in the web browser. It works almost like that in the Flutter when we've got hot reloading, and when we save the file, mobile application, in this example, reloads almost instantly, and we can see the result. It's great, but that's not only that. Other advantages is that it's fast, and I mean really fast. It runs in 60 FPS on most devices, and on some devices, like the latest Samsung devices, it runs even higher on 120 Hz, because the screen can handle that, and the CPU and GPU too. So it's fast and convenient, like web platforms, but with a lot more advantages that web wrappers do not have. Okay, but I sound like a PR person and not like a technical person, so it might get a little bit boring now because I'm talking, it can do this, it can do that. Great, but exactly how does it work? Because, you know, we are technical people, so we would like to know, how can technology like this work? I would say that Flutter is more like a game than a typical framework. And I'm going to explain that. When we are writing a typical application, we are using system elements underneath. But here, when we are rendering something, Flutter renders elements on canvas. That's why application that have material elements or iOS-like elements can have the same UI, pixel perfect, almost pixel perfect, because it's rendered on the canvas. So it doesn't care about the operating system and what the provider of the OS, Apple or Google, gives us, or Microsoft on the other hand, on the Windows. Because we are not doing that. Instead, we are using a Skia, also Google library, that renders that with a canvas. That's an example from the official documentation of the Skia library. We don't have to look at that too much. The most important thing is that it's rendering on canvas. And pretty much everyone uses canvas. But why exactly Flutter is using Skia library? That's quite a good question, because, you know, optimizing a framework or anything to run on 60 or more frames on mobile devices that have limited resources, very, very limited resources, is very hard. You know, and I don't know if any of you wrote some low-level graphic thing in Vulkan, Metal, or OpenGL. I would like to say it's hard. You have to do a lot of manual labor, like creating frame buffers, and on Vulkan even more. You have to create descriptor put, descriptor set, command buffer, commands, a lot of things, and you have to use those things properly, or you will get really, really bad performance. Flutter with a Skia library does it completely for us. And Skia has got a lot of backends, like as you can see, OpenGL, Vulkan, and Metal. It's for mobile platforms, but also Skia has other backends, like WebGL, and that's why Flutter applications can be rendered in the web browsers too. Okay, let's continue. I also said that Flutter is really fast, and you know, we know that's partly because of rendering that's done with Skia, but that's not all. Flutter in debug mode runs in the virtual machine. That's why we can reload the code just like that, because part of the code can be easily, behind the scene, changed and reloaded in the virtual machine. That's a great solution. I know most of you use virtual machines, like in Java or other technologies, but it has some problems, and one of them is performance. I would say the bigger the virtual machine, the better it is, but the performance is compromised. And that's why Flutter only in debug uses a virtual machine, and in the release mode, it compiles to the native code, to the proper CPU architecture. Let me give you an example on the iOS. On the iOS, they created a proper frontend for the Dart language, where they put that code, that intermediate code, into the LLVM, low-level virtual machine, the compiler, and then it produces the proper assembler, the low-level machine code, I shouldn't call it assembler, machine code for the proper CPUs. That's why it can be so fast, and that's why it can provide us with so many frames, as I could say. So continue. Architecture. Flutter architecture is quite complex. We don't have time for that today, to analyze that, but all I wanted to share with you today is that the Flutter uses Dart only for us, I would say, and it uses lower languages like C, C++ for the core parts of it. That's why it can provide us with a much lower level of access for most of the core things. Okay, let's continue. I was talking about Dart many times, and I said that I will come back to this, and that's the time when I should get into the details about the language. If you wrote anything in modern programming languages, or even not so modern, because C is old, but it looks pretty much the same, but it's more like a Kotlin, Swift. It's just programming language like any other, but it's got some interesting things that I would like to show you today, and why it leverages the possibilities of the Flutter, and why Google had to create a proper language for the Flutter, and why they couldn't use other technologies, other languages, I should say. First thing, access modifiers. In different languages, we can access modifiers with different keywords, like private, protected, public. In Flutter, we don't do that. Instead, we use naming. If we add underscore, the thing gets private, like method, class, variable, anything gets private. What class with underscore means? It means that's a private class that's only accessible from that file. So if the class is, if we have got some public class, then that class can access it in the same file. Okay. Another interesting thing, methods. Just like in any other language, we can call the method, but that's not all. We can have optional parameters, and that's pretty interesting, but nothing interesting, to be honest. But we can also have, like in some languages, optional name parameters that we can pass. Only those parameters that we need, and we can set those parameters if we don't want to pass them, for example, to default values in the method. I didn't done it here, but we can do that, and we can pass only those parameters. It's one of the most strengths of this language, because with this approach, we can create really great UIs. I know some of you still might not believe me. I'm going to show it in a minute, but this is one of the most interesting things in this language. Also, there's a null arrow operator with double question marks. We can default to another value if it's null. Also, we got a support for async, await, and feature, so fully asynchronous code can be written in Dart without any kind of magic. And it's all great. By the way, you can test that for free now, even, on the site dartpad.dev. Where the free tool for testing the code is available. You can write anything, and it will just work in the browser, because like I said, Flutter or Dart programming language can be run anywhere, and even you can create here a small Flutter application, because it runs in the web browser fully. So you can do that here, if you would like to. Okay, but I said that you can implement UI easily with those optional naming parameters. How you can do that? Here's a simple application, really simple. Let's try to write something like that in an Android native, where you have to create XMLs and other files. That's all we have to do. What we do, we just call material application, we pass optional parameters, title and home, and then we pass another parameters in the scaffold, optional, just constructor with optional parameters. We do that, and as a result, we get something like this. Okay. You might think it's a little bit scary, but let's add something to the screen, like an up bar. If you add that up bar in other technologies, you might think it's hard, but not in Flutter. We just have to pass to the scaffold another element, another widget, I should say, up bar. To the optional parameters up bar. As you can see, there is no such thing in the scaffold here. We just add it. And as a result, we'll get an up bar with a title. We can do anything we want. We can add a column with widgets, like with text or with buttons. We can do anything we want, just like that. Some of you might still not be impressed with that, but this approach was, I think, it was started with the Flutter, and now it's implemented in more and more technologies. For example, Apple implemented that on the iOS platform with SwiftUI. Google added that, more or less added, because it doesn't look that good, with Jetpack components on the Android with native applications. So it's spreading across the industry because it's a really convenient way of creating UI elements, declarative way. Okay, but what can we do with that? I was talking about the UI, so you can, out of the box, render pretty much anything that is from material design, from Google Material Design, like those are just 3 elements, but you can just like that add those elements with a line of code. You can also add iOS style items, just like that, Cupertino button and other elements. Those are just 3 examples. But you can add those items with just a 1 line of code, because it's already implemented into the framework. And it's great because we can create really great looking applications out of the box. And if we need something custom, we can program that. We can get a little bit lower and implement anything we want on ourselves. Okay, but creating UI is not everything in our world. Let's say we've got an older application. You know, we've had an application that was created 5 years ago, written in native code. We have got some native libraries that we have to use. We are forced to use them due to the backward compatibility. We can do that. We can use those libraries with method channels. That way, Flutter, via Dart language, can call Java code, Kotlin code, Swift, Objective-C, or even it can get level lower and call the C++ code, do something, and return to us the result. So that way, we can have any older parts of the application that do some kind of calculation or anything, or call some backend server. We can do that. We can do that with Flutter. It's implemented the language. It's called method channel. Okay, but let's say we've got a little bit harder case. We don't want to add something that calculates something. We want to display some native views. Also, Flutter can do that. We can display any native element that we want, that we have, for example, from some library. We can do that. There are two ways in the Android: hybrid composition and virtual display, and hybrid composition on the iOS. It works quite good, I would say. There are some performance issues. That's why on Android we have got two approaches, but it works. Here's an example of displaying something really low level. It's written in Vulkan API, so it's getting to the GPU. And it is displaying the rectangle. I know it doesn't seem like much, but it does a lot of code in the C++, and it can be embedded into the Flutter in 10 minutes, 15 minutes. We just have to call it to display it in the native in the Flutter application via native views, virtual display in this case. Of course, rectangle looks ugly, and I know that some of you might say, I don't want to display rectangle. I need something more from my applications. I need more performance. You can also do that. This is from the last year presentation that I did for low-level graphics programming. If you are working, for example, in the automotive industry, you can display, like in this example, completely native activity on Android, I would say page, and it can work completely separately from the Flutter, and we can write the rest of the application in the Flutter. That way, we'll have the great performance on some screens, some pages, and we can have the shared code of the business logic. Okay, but I was talking a lot about how it can be done in theory, you know, in some kind of demos, tech demos, but tech demos doesn't represent the real world. And I know that showing something that it works on the graphs and something like that, virtual machines, a lot of things, it sounds great on the paper, but how about real application? At ING, we used Flutter when it was still in beta. We started the development. And we use that for one of our core projects, ING Business Mobile. It's a mobile application for corporate clients. We used the Flutter. We had some libraries from the previous version that we had to use, for example, for security or for networking. We added that to our application, and it works. It's on production for, I think, a year now. It works. Solving problems is great because we can solve that in one place, and it solves on both operating systems. So this is an example that it can work. This is just in a number that applications uses 41,000 companies, almost 42,000 corporate clients, so a lot. Okay, but let's get to the details about our application and that it works. Like I said, calling native methods. Do we use that? Yeah, I already said that. From the Flutter, we use native libraries for networking, security, biometrics. We created a lot of security layer at this point for operating, for connecting with the client to provide encryption, to provide elements like connecting with server with different architectures. It works. It solves the security problems. And what can I say? We are using that on production, and we didn't have problems with that. And we are also displaying native views. For example, for our video verification, maybe this is not the best screen, but for the video verifications, a user can look at their phones, rotate the head, like on the iOS, like with Face ID on the iOS, then scan their ID card, and then it's verified that this person is this person. And we are doing that with Flutter. It's delivered to us from third party. And the third party was not ready for Flutter, so they deliver us native elements. And those native elements fully work. We are displaying those elements, and they are undistinguishable from the Flutter element. They look the same, pretty much. So we are displaying them. They work great. We don't have too much performance problems with them. Of course, some performance we have, but it's really marginal. So I don't think it's a problem, that big of a problem. Okay, let's continue. Let's get something bigger. 3D elements. Because I said that it can be done by only showed red rectangle. Yes, we have got 3D elements. Also on the production, not with such low level as Vulkan, but we have them. We have a rotating 3D card. Also, this element works. It's fully animated. User can interact with the card, and this works without any performance issues. To be honest, it doesn't have almost any performance hit on most of the devices displaying this card. Complex UI with animation, I already mentioned that, but this screen has animated elements. Also, we have a login screen with moving elements. Adding animations to the Flutter is quite easy because Flutter already provides a lot of things, for now let's call it things, for animating the screen. And we can just use them for moving elements on the screen. Okay, something a little bit harder, notifications. Notifications are quite hard because we have to start the application, and besides starting the application, we have to pass the data to the application. It was a small problem for us, but it also can be done. Currently, there's even an official library from Google for that, that provides the notification just for the Flutter. So all you have to do is implement few methods, and it starts the Flutter, runs the proper code, and we can receive the data from the notification. Of course, there's much more. And I just wanted to show you the technology, not to get into showing how you can write that, because Flutter has got a really, really great documentation that I highly recommend. In this documentation, you can find pretty much anything you need. I know that some of you might feel scary to the documentations because some technologies has got really bad documentation, but Dart has got and Flutter has one of the best documentations in the world. And you can find anything you want. You can try, like I said, Dart in the Dartpad, and you can try that out for free. Okay, let's sum it up a little bit, because we are getting to the point. Is Flutter ready for enterprise-grade projects? It depends on the project. If it's the application that has got only some kind of really hardware-specific logic, great, I would go for the Flutter. When it is an application that requires a lot of 3D content, like navigation or something like that, then I would consider creating something native, because in this case, we need more performance, we need more battery when we are driving the car. But when we are writing applications like banking applications, and most of the applications that we create, I think the Flutter can solve most of our problems with one code base and with one bug to fix, and not two bugs on two different platforms with two different languages, with two different development teams that have got two different Scrum tables that have to schedule that task to be fixed. That's why I think Flutter is ready and is going to be developing even more in the future, and is going to push some of the other technologies out of the market. But that's my opinion. Okay, I finished 25 minutes, a little bit faster than I should. probably. But that's pretty much it that I wanted to share with you. If you have got any questions, you can ask it now or later. But you can ask it now, we have got time.
Hi, so you develop a banking application. So you probably use HCE, hardware card emulation for your application, or do you use the native methods?
In our application, in this application, we are not using yet hardware card emulation, but we are going to do that in the future.
So because I have a problem, so I was very interested in this talk because I have a problem. I have to create an application which does use two-way communication with HCE, and I did not find anything on Flutter that can do that with because those are actually system-specific things how you communicate with the HCE, right?
Right, but I think you can create a method channel and communicate with the Flutter with the streams. Method channels accept the streams. That way you can return multiple values and pass multiple values in different times. So you can use those ugly, for example, Java callbacks. I don't know if that will solve your problem, but we are doing that with one of our libraries that can return multiple values in the callback function.
But are those channels that you talk about, they require actually native code written to communicate with HCE, right?
Right, you have to write the native code, right?
Okay, cool. And also, if you just have a Windows machine, can you compile an iOS application from your Windows?
No.
So you have one code base, but you need two machines to compile, right?
Or one machine with Mac operating system.
Oh, okay. Well,
but that's not the Flutter fault. That is the problem with signing the application that is required through the Xcode. You cannot do that on the Windows machine because you don't have an Xcode. So cannot sign that application anyway.
Okay, and last question, if I may. Can you write UI elements like I want to have material buttons on Android and Cupertino buttons on iOS, so I can write one element that will just render differently on each system, right? Yes.
You can create your custom widget, for example, to be more easy to use then, to reuse, to be more usable, and you can just add if then. If platform is iOS, then you render that, and on the Android.
I thought that was native, solved natively somehow in Flutter.
No, Flutter is designed to be pixel perfect, so it just passes the same.
Okay, makes sense. Thanks.
UI. So, if that's it, thank you for your time. If you have got any questions, you can ask me after this presentation. Like I said, thank you.